Welcome to Rges Algebra 2. This is lesson 1.3, Variables and Expressions. I want to remind you to be sure to read each section, as I am only explaining the highlights, and the text is very well written, and you want to catch all the details by reading through it before you start your problem solving. The objective for this assignment for this section is to evaluate an expression by substituting a given number for the variable and finding the value, or simplifying an expression. Let's talk about two definitions before we begin. Variable. A variable is a letter which stands for an unspecified number from a given set. So if we have x plus 3, I know the value of the constant, but this value I do not know unless I solve it in an equation. You can't solve it in an expression, or it is given to you as something you would substitute. For instance, you could evaluate this expression if I knew that x equals 4. The second term we want to remember is expression. An expression is a collection of variables and constants connected by operation signs, which stands for a number. So I could have an expression and be able to evaluate it. Let me give you an example. I can evaluate this expression if I am given a value for the variable. Recall how you do this, and I am modeling, by the way, the form in which you want to do this. Go down to the next line, and every time you see an x, I want to substitute the value 4. Then I want to follow order of operations, needing to square. I can feel free to do this multiplication because it does not interfere. I need to do this multiplication next. That would be 48 plus 20 minus 7. That would be 68 minus 7, or 61. Be sure to circle your answer, and this should look very familiar to you from Algebra 1. Recall that subtraction is merely the addition of the additive inverse. In other words, if I had x minus 3, that would be the same as x plus a negative 3. In the same way, division is simply multiplication of the multiplicative inverse. If I had x divided by 4, that is the same as x times the inverse, or the multiplicative inverse is the same as reciprocal. The reciprocal here would be of 4 is 1/4. Recall that exponentiation, or finding the value when you have an exponent, if I have x to the 5th, this is the base, this is the exponent. Altogether, x to the 5th is called the power, or x to the 5th power, and it stands for a repeated multiplication of the base. The base is x, and how many times do I repeat that multiplication? As many times as the exponent says. So that would be x times x times x times x times x. Review for a minute order of operations. We always do what's in the grouping symbols first. Grouping symbols could be parentheses, brackets, braces, or a division or fraction sign where you must do everything above, everything below, so it's an implied grouping before I do the division. Next, I would do any powers, or exponentiating. Next, then I would do multiplication or division from left to right. And then I would do addition or subtraction from left to right. And this again should be reviewed to you. Part of your problems in this section will be solving or simplifying expressions. So though I was careless a minute ago, we do want to call it simplifying an expression. You only can solve equations. And remember, an expression that never has an equal sign or a not equal sign or a greater than sign. Nothing that compares it with another expression. Only variables, operations, constants, right? This would be an expression, but not an equation. Okay, let's look at some examples now. Example number 1 says 3 plus 4 times 5. I would have to do that first. You don't have to underline it when you show your work, but you do have to go to the next line and put equal. 4 times 5 is 20. Finally simplifying that, 3 plus 20 is 23. Next we have 3 plus 4 times 5 divided by 2. We're going to do this multiplication, remember from left to right, multiplication and division. So this would equal 3 plus 20 divided by 2. Next we would have to do our division. 3 plus 20 divided by 2 is 10. And finally, the answer is 13. So you'll have a couple more examples. Go ahead and look through them. This is just reminding you of things you know from Algebra 1. Something else we need to remind you of is absolute value. And remember, absolute value can be thought of as the distance from 0 on the number line. So if I have 4 here and -3, the absolute value of 4 is what is the distance between 0 and 4, and that is 4. What is the distance between -3 and 0, and that is 3. So it's always the positive counterpart or expression of the value. Absolute value of 5 equals 5. Absolute value of -7 equals 7. Always, a distance would always be positive. And absolute value of 0 is always 0. Okay, let's look at example 3 on page 12. You always substitute first when I've got an expression like that or a statement like that. I substitute every time I see my x. 17 minus 4 times 5 minus 2. My absolute value sign would be considered a grouping symbol, so I have to do everything within it first. Within that, I'll have to do my multiplication first. Now I have to do my absolute value. 17 minus 20 is -3. And what is the absolute value of -3? Would be the positive counterpart, 3. And finally, 1 is my answer. So hopefully that looks familiar to you. Go ahead and check out the next example in the book, and let's talk about a couple more ideas. On number 4, on page 13, I'm going to show you a little bit simpler way to think about this than he presents to you. His is certainly accurate, and it would be good to look through that, but I would just simply write this as 7x times 2 divided by x. Now, remember, you have to simplify. Well, this is not exactly true because we can cancel at this point whenever we have factors. In the numerator, I have factors. That's a multiplication sign, not a subtraction sign there, though it looks a little sloppy. So whenever I have just things being multiplied together, I can cancel. I can cancel those and simply come up with 14 in the very next step. Number 5. Recall that when you are doing nested parentheses, that would be an inner parenthesis here and an outer parenthesis, I have to start with the innermost first. So on my next step, I would copy down everything just as I see it. But here when I get to this, I cannot simplify what's inside, so I'm going to have to distribute. So this becomes negative 5x. Negative times a negative is a positive. 5 times 1 is 5. Now what I'll do is to simplify what's in this large parenthesis, I'm going to gather like terms. This becomes 2 minus 3, copying everything as you see it. My x's, I have x minus 5x or minus 4x. My constants, I have minus 2 plus 5 or plus 3. Next, because I cannot gather those because they're not like terms. I have an x value and a constant. The only thing I can do here to simplify is distribute. So this becomes 2 minus negative times the negative is a positive. 3 times 4x is 12x. Negative times a positive, as I'm now doing this, that's negative 3 times positive 3. That's going to be a negative, and 3 times 3 is 9. Gather constants. 2 minus 9 is minus 7. And now I'm finished. I cannot simplify this anymore without knowing a value for x. I want you to look at do these quickly exercises 1 through 10 on page 14 and 15. Stop the tape long enough to work them out mentally and only come back if you cannot figure out what to do or to check yourself. The first question is the square root of 9. Is that an integer? Well, we do have to simplify it, and the square root of 9 is what do I multiply by itself to get 9? And the answer would be 3. Is 3 an integer? The answer is yes. Is negative 4/7 a real number? Recall, real numbers are made up of both the rational, which means ratio, which means fractions, and the irrational, like roots that cannot be simplified, square root of 2 or something like pi. This is indeed a rational number, so the answer is yes, it is a real number. Commute the 3 and the x. Now recall that commuting has to do with changing the actual order, moving these two, the 3 and the x, I want them to trade places. So my answer should be 2y plus x plus 3. Associate the 4a and the 2c. So we have 4a plus 2c plus 5d, and I want to associate them. How would I do that? By adding parentheses. Distribute the 5. When I have 5, 3x minus 7, recall, it becomes 2 multiplication problems. Added together, this would be 15x minus 35. Write the additive inverse. The additive inverse is the negative. So if I have 5/8, the additive inverse would be negative 5/8. Number 7, write the multiplicative identity element. That would talk about, now, let's say I have 7. What do I have to multiply 7 by to get 7 when I'm done? And the answer would be 1/7, or the reciprocal. So, I'm sorry, I was talking about the inverse. Let's try that again. What do I multiply by 7 to get 7 when I'm done? And the answer is 1. So 1 is the multiplicative identity element. Number 8, if 3x equals 42, what does x represent? I'm asking myself, what must I multiply by 3 to get 42? And of course, I would just simply divide the 42 by 3, and I would get 14 as my x. Multiply 2.3 times 4, and we're going to have a decimal when we're finished. 2 times 4 is 8, and 0.3 times 4 is 1.2, so we're going to get 9.2. That would be how I would do it if I'm doing it in my head. Otherwise, you could do it certainly like this. You'd get 12, 8, 9, and a point. Finally, divide and simplify. It says 2/3 divided by 6/7. 2/3 divided by 6/7. To divide means to multiply by the reciprocal, so this is the same as 2/3 times 7/6. Cancel where you can, and this becomes 7/9. So all of that should be review skills for you.